In this video, we're going to talk about volume and surface area of three-dimensional shapes. In the IB, there are 5 three-dimensional shapes that we're going to be focusing on: prism, pyramid, cylinder, cone, and sphere. And it is expected in the IB to know what those shapes look like by just saying, here is a pyramid, right? So we're going to go through all of these shapes, and we're going to also talk about all the formulas that are in the formula booklet and those that are not in the formula booklets in order to answer questions about volume and surface area. First, let's talk about our prism, which is the most common shape that we see in the IB. A prism is a 3D shape that the two bases are similar and parallel to each other, and all the other shapes are rectangles. Let's change this to rectangles. So on the right, you see a bunch of different prisms, and all the prisms take their names from what the base is. So the first one is a triangular prism. Then we have here, it seems to be a cube if all these sides are the same, right? So if it's a cube, then every single side is exactly the same. We have a hexagonal prism, and so on and so forth. A special name for a prism in the IB is for the rectangular prism. If you see rectangular prism, the IB often is going to be using the keyword cuboid. And they give you the volume equation for a cuboid in the formula booklet, and this is your length times width times height. And then they also give you a volume equation for all other prisms, which is capital A times H. Now the IB says that this capital A is called the area of the cross section. Now what does this mean, cross section? It actually just means the area of the base. And you don't have any formulas for surface area. So you just have to know that when you're finding the surface area, you're adding up all of the faces of every single face you have in a 3D shape. So the sum of all the faces. Therefore, in a prism, there's going to be 2 identical bases. And then there's going to be rectangles depending on how many sides their base has. So if it's a triangular prism, the base has 3 sides, so there's going to be 3 triangles. The examples we're going to do in this video is fairly straightforward, but when we're going to be in class, we're going to practice a lot with more complex shapes, which means a combination of shapes put together, and then different contexts as well. So let's start with this example. Find the volume of a triangular prism whose base is an isosceles triangle where the equal sides are 12 centimeters and the angle between them is 130. The height of the prism is 15 centimeters. So the height of the prism means the distance between my 2 bases is 15 centimeters. In order to find the volume of a prism, we use the equation, which is area times height. The area here is the area of my triangle. So I have a triangle where I have 2 sides and the angle between them. So I can use the equation 1/2 AB sine of C, while the height is 15. So let's go ahead and substitute the values in the equation. We have 12 times sine of 130, and then times 15. Go ahead and put this into the calculator. And we get that the answer is 827 rounded to 3 significant figures. Now let's look at the other shape. The next shape we're going to look at is a pyramid. And in this course, we're always going to be looking at a right pyramid. So whenever you see the word right, it simply means that the apex is directly above the center of our base. So it forms a 90-degree angle at the bottom here all the time. And what is a pyramid? Well, a pyramid is any base whatsoever. And then what is happening is we are having other triangle faces that are connecting our base to the top, which is called the apex. There's a few different measurements in here that are important. The first one being the height. So the height, or the vertical height, is going to be this distance from our apex to the center of our base. Often we use the letter H for this. And then there's another measurement which is called the slant height. The slant height is going to be the apex to the side of our base. So this slant height is not the same thing as our height. And we have some formulas given to us in the formula booklet. The formula for the pyramid is 1/3 capital A times H. And this time the IB booklet is nice, and they say that capital A is the area of the base. So no more cross-section stuff, just the area of our base. And in order to find the surface area, we don't have a formal equation for the surface area. So this one we just have to add up all of the triangles together and then finally add up the area of the base. So it's the sum of the base, there's only one base, and all the triangles. And there's the same amount of triangles as there are sides in the base. Let's look at our example. A right pyramid with a regular hexagon base has a vertical height of 5 centimeters. Each side of the hexagon is 4 centimeters. Find the volume of the pyramid and give your answer as a decimal. Correct the 3 significant figures. First, let's look at the base of our hexagon. So let me try and draw a nice hexagon. A hexagon is a polygon with 6 sides, and the hexagon is regular meaning all the sides are the same. Whenever we have a polygon which is not triangle or quadrilateral, then we need to break it up into triangles. So I can break this hexagon into 6 identical triangles. Let me try and make this hexagon a little bit bigger. So breaking it up into 6 identical triangles, I get that one of these angles is 360 divided by 6, so each angle is 60 degrees. And since I have a triangle which is isosceles, these two sides are exactly the same, well, that means that 180 minus 60 divided by 2 is also 60. So whenever we have a hexagon, these triangles that are created are actually equilateral triangles. So I can find the area of this equilateral triangle because I know that the two sides are 4. So I can have 1/2 times 4 times sine of the angle between them is 60. And when you put that into your calculator, you get that the area of one of these triangles is 6.93. So let's go ahead and think about the whole pyramid. So the pyramid has a hexagonal base, again, trying my best here, and then a pyramid connects it to the top. And we know that the vertical height, so from the apex to the center of our pyramid, is 5 centimeters. So the volume is going to be 1/3 times the area of my base times the height. And when you put that into the calculator, you get that the volume is 11.55, and we're asked to round to 3 significant figures, so 11.6 centimeters cubed. Now let's talk about another shape, a cylinder. A cylinder is a shape very similar to our prism. We have 2 parallel bases. However, the 2 parallel bases are circles. So therefore, it's not a rectangle connecting, not many rectangles connecting between the 2 bases, such as we had for a prism. So a cylinder, 2 circles, and then connected together by a curved surface. In the formula booklet, we have the volume of a cylinder, which is pi r squared times the height. And we also have the curved surface. Now, the curved surface is only the curved part between our 2 circles. And we have this in the formula booklet as 2 pi r times h. Now, when you're doing the surface area of a cone, it's important to add both the curved surface, but also the area of our 2 bases. And we do have the area of a circle in the formula booklet, pi r squared, but whenever you're doing surface area questions involving cylinder, make sure that we add our 2 circles and the curved surface. The next shape we're going to look at together is a cone. And in the IB, again, similar to our pyramid, we're going to have a right cone, meaning that the apex is directly above the center of our circle, creating a 90-degree angle with the radius. we have some formulas in the formula booklet, which is the volume of a cone is 1/3 pi r squared times the height. And then we also have the surface area of the curved part. So the curved part is everything that is not the base of the circle. And this curved part, the area for it in the formula booklet is pi times r times L, where L is our slant height. So it's not the vertical height, but it's the distance between the apex to the side of our circle. And then, of course, if we're finding the total surface area of a cone, we have the curved part, but we also have the circle part, where we have the area of a circle is always pi r squared. Let's look at this example. A waffle ice cream cone has a diameter of 5 centimeters, a slant height of 12. What is the correct calculation to calculate the volume of this cone? So let's first draw our cone to the best of our abilities. This is our cone. We have a diameter of 5. We have a slant height of 12. And we're looking for the volume. So we're looking for 1/3 pi r squared times height. So we know the radius is half of the diameter. So my radius is going to be 2.5. But in order to find what the height is, which is this measurement right here, creating a right angle with our radius, we need to use our triangles. So we now have a right angle triangle where we have one side is 2.5, the hypotenuse is 12, and we're looking for our third side. So I can use Pythagorean theorem here to find out what the height of the triangle is. And we get that the height is 11.7. So I can add the 11.7 into my equation, and I get that the whole volume of the cylinder is going to be 76.6 centimeters cubed. And now for our final two shapes, the sphere and the hemispheres. Now the sphere has all the equations given to us in the formula booklet. However, the hemisphere has no equation given to us. So first let's talk about the sphere. The volume of a sphere is 4/3 pi r cubed, while the curved surface area of a sphere is pi r squared. Now we think about this and we think about the hemisphere, which has no formulas. Then the volume of a hemisphere is going to be half the volume of a sphere. So we can leave it like that. However, when we talk about the total surface area of a hemisphere, we have now two parts created. The first part is the curved area, which the total surface area of the curved part is half of the surface area of a sphere. But we also have this circle that was created by cutting the sphere in half. So we also need to add the area of a circle. And when you simplify this, then we get 2 pi r squared plus pi r squared. So therefore this simplifies to 3 pi r squared. Now, you never need to remember this formula by heart because you can always go with logic as well. But I just wanted you to be super careful when you're doing the surface area of a hemisphere. Now, we've looked at some very basic questions and we've just introduced every single formula which is in the formula booklet. Now, the important part is doing some IB past paper questions to understand what they can ask with all these formulas.